Okay, number 173. This is a classic merit level problem. And the deal is you're told that the area, this color here, is 40 units squared. And you're told this curve is function f of x up here. And you have to solve for k. At what point, if you kept stretching it or reducing it here, would that area equal 40? So let's look at it in terms of this bit here. So straight away, I've got rid of the surd sign and I've brought it up here. And in theory, I'm going to make a statement. I'm going to say between 5 and k, the upper limit k, the smaller limit 5 of this thing here, 20 square root 2x minus 1 to the power of negative a half with respect to x is equal to, I think it was 40. So the first thing I'm going to do is put the 20 over here. And in fact, let's just cancel it out now. And so we've got it down already to this expression. It's starting to look a lot more friendly. Okay, so let's just make that a bit neater. So what's the deal here? We're going to use the substitution rule. Let u equal 2x minus 1. Du by dx is 2. Therefore, we could say dx equals a half du. So if we then put this into the expression here, we could say integrate, replace the 2x minus 1 with the u to the power of negative a half. And that, and what's the, missing the dx, sorry, that dx is this thing here, a half du. And let's keep going with this. That half pops out the front. Integrate u, negative a half du, a half u. What happens? Add on 1. So add on 1 becomes positive a half, and divided by a half. And what happens to that half there? Okay, that half is going to jump up and become a 2, and the 2 is going to cancel out. So our expression becomes u. Okay, now this is interesting. At this stage here, that technically is still x equals 5 and x equals k. So what I need to do here is replace the u with the substitution. So we've got 2x minus 1 to the power of a half, k and 5. And that is equal to, I think we get it down to 2 here. Okay, now substitute in. So that's going to be 2k minus 1 to the power of a half. 5 goes in here. 2 times 5 is 10. 10 minus 1 is 9. 9 to the power of a half is conveniently 3. Okay, running out of room. 2k minus 1 to the power of a half equals 5. 2k minus 1 equals, what's this? 25, because you're squaring both sides. And then 2k equals 26. K equals 13. Right, so that is the official answer. If that was 13 up here, that would be the area. Just as a side tangent, here I put my notation. I said, the limits here, this was in terms of x, but if we did the substitution here in terms of u, we could also do the same thing up here. So just as a wee bit over here, let's bring this over here. We've got, and looking at this bit on the left here, let u equals 2x minus 1. Okay, so when x is 5, x equals 5, what does u equal? 2 times 5 is 10, it's going to be 9. So, and when x equals k, therefore u is going to be 2k minus 1. Replace the x with k. So, in other words, the integral symbol, instead of 5, we're going to put 9. Instead of k, we're going to put 2k minus 1, and that is u du. Now we've got everything in terms of u. Let's see what happens. So the same process, we're going to integrate this. You get u, it goes a half divided by a half. Okay. and 2k minus 1 and 9. Now what happens here? Divide by half, that means it's times by 2. The 2 cancel out, so we've got u a half, 2k minus 1, 9. Okay, plug in the numbers. That becomes 2k minus 1 to the power of a half minus 9. That's 3. Oh, by the way, the whole thing here, as we said, is equal to 2, equal to 2, equal to 2. And as we can see, that is the same as that step there. So eventually out pops k equals 13. Right, just a confirmation. Let's just confirm the answer is 13. So we're going to turn on, we're going to go integrate, and we're going to say the function is this thing up here, 20 times bracket 2x minus 1 bracket power 0.5. Oops, that's negative 0.5. Yep. Okay, bottom limit is 5, upper limit is 13, and there's the answer, 40. So that confirms that if we do have k as 13, then that area is, well, the calculator's also confirmed it for us, is exactly 40.